Hello ladies and gents, this is Daniel and we're back to the Scala basics, and in this particular video we will talk about functions. Cool, so in IntelliJ let's create a new Scala application specifically for this lecture. You've already got the hang of it, so right click on the lectures.part1 basics package, new Scala class. We'll name this functions, and in the dropdown we'll select Scala object. Okay. And then at the end, we'll say extends app. Again, this is for this code to be runnable by IntelliJ. Now, without any further introduction into why functions are useful, because you've probably got that lecture from other languages before, I'm going to define a function in Scala. And the syntax is def, so this is the keyword for defining a function. I'm going to call this a function. And in parentheses, I'm going to specify parameters, and each parameter has a name and a type. So a : string is a parameter named a of type string. I'm going to add another parameter, say of type int, and this function will return a string. So : string at the end is the return type of the function. After the function definition, or the function header, or the function signature, if you will, at the end we'll put an equal sign, and then we'll specify the implementation, and after the equal sign follows a single expression, which is the implementation of the function. And the implementation of the function that I want to write here is the concatenation between these two parameters separated by a space. So I'm going to say a plus a space plus b. This plus here is string concatenation. Okay, so this function takes two parameters, a string and an int, and concatenates them with a space in between. So again, syntax is def, name of the function, in between parentheses the parameters, each parameter has a name and a type, then : return type of the function, and after the equal sign, the implementation of the function, which is a single expression. Now, because you've learned about expressions in the previous video, you now know that expressions can also be blocks, which are often used in practice. So if, for example, we move this expression into a code block, this is still a valid function definition because a block is also an expression and its result is the value of its last constituent expression. Let me bring this into presentation mode so that you can see this more clearly. Now, the way that we call function is very likely to be familiar syntax to you from other languages. So if I print line the call of a function with parameters hello and 3, I'm going to see the string hello space 3 to the console, of course. So the way that we call a function is to simply name it, and in between parentheses we pass in some actual values for parameters. Now, like everything else in Scala, calling a function is also an expression, right? Because we can use the call of the function as is in the print line statement here. Now, one new thing to bear in mind though, parameterless functions can also be called with just their name. So if I say a parameterless function, which takes no parameters, and say it returns an int, and say we return the number 42, we don't really care. We can print a parameterless function like this with the parentheses like we would call a function, or we could print a parameterless function without the parentheses, and the compiler will warn us that empty paren method accessed as parameterless. So parameterless functions can be called with just their name, so keep this in mind. I'm talking particularly to people already exposed to functional programming, where the syntax could mislead you into thinking that this is the function itself. Alright, cool. So you now know how to define functions. Now, let's define some more ambitious functions. This was pretty basic. Let's define another function that instead of concatenating a string and an int, now concatenates the same string n times. Now, in a normal programming language, for such a function you would use loops, but I want you to get into the habit of using functions instead. So this is what I promised I would show you when thinking about loops in a functional language. So let me show you how I'm going to do it. So I'm going to define a function. Let's call this a repeated function that takes a string as a parameter and an int which says how many times I'm going to repeat this string parameter. The return type of this function is going to be a string, and its implementation is going to be, watch what I'm writing. So if n is equal to 1, I'm going to return a string. Otherwise, I'm going to return a string plus a repeated function called with the same string and n minus 1. So this is a recursive function because it calls itself. And the IntelliJ is smart enough to figure this out for me, and it says method a repeated function is recursive. Now, if I call this function, and let's say I print the application of a repeated function with the string hello and the number 3, I am expecting to see hello concatenated 3 times and printed to the console. So let's right click and run this. And we see hello, 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 of course. That is because we call this repeated function recursively, and at some point, a repeated function got into the n equal 1 base case, so it returned a string, and then the repeated calls or the recursive calls concatenated a string later on, okay? So what I want you to take away here is that when in a normal programming language you would use loops, in Scala or in a functional language you use recursive functions. So I'm going to write this in all caps. When you need loops, use recursion. This is a fundamental idea of functional programming. Even if you get this one idea right out of this course, you're already ahead of half of Scala programmers. Again, the worst thing a Scala programmer can do is use imperative code with a Scala syntax. Now, before I move on, I wanted to talk a little bit about types, about return types of functions. So, as is the case that the compiler can infer the types of vals or vars, so the compiler can figure out the return types of functions if we don't specify it. So let's go to the first function and just remove the return type of this one. So watch what I'm writing. You may not need to do this on your own code, but watch what I'm doing. So the compiler doesn't really complain if I delete the return type of a function, and indeed if I hover over it, it says it still returns a string, and the compiler figures that out by looking at the implementation, which is the expression concatenating some strings. So the compiler figures out that the return type of this expression is a string, so a function must return a string. So the compiler fills out the definition for me, even without me needing to specify the return type explicitly. But if I delete the return type from a recursive function, the compiler will complain. So it says the recursive method a repeated function needs result type. All right, that's because the compiler cannot figure out the return type of a recursive function on its own. I'm going to show you a little diagram a little bit later, but for now, just remember to put in return types of functions, especially if they are recursive. As best practice, always specify the return types of functions nonetheless. All right, so I'm going to undo what I just deleted. All right, speaking of return types, you can use unit as a return type. That means you define a function as only executing side effects. So if I say def a function with side effects that takes, I don't know, a string as a parameter. I'm going to name this parameter a string. The type will be string, and the return type is unit. And the implementation is going to be something that returns unit. Now, what is something that returns unit? For example, print line statement. Right? So print line something is still an expression returning unit. We normally need functions with side effects if we want something that has nothing to do with computation itself. For example, printing something to the console, displaying something on screen, logging something, or writing to a file, etc. But you know about the unit return type already, so I'm not going to bore you anymore with it. All right. Now, another thing which might not be a shocker. We said that you can have code blocks as the implementation of functions. We also said in a previous video that in code blocks you can have auxiliary definitions. Now, here's the shock. Code blocks also allow you to define auxiliary functions inside. So if I define a big function with, say, a parameter and which returns an int. I don't really care the types of parameters or the return types of functions here. I only care that I show you that you can define auxiliary functions inside. So if I define a smaller function, which receives, I don't know, how many parameters you want. Of course, I've forgotten the equal sign here. And it just returns an int, say a plus b. You can actually use the functions that you define inside the code block to determine the return type of the big function that you implement. So if I call a smaller function is inside, a smaller function with n and n minus 1, this is the return type, the return expression, sorry, of the implementation of a big function, all right? So you can use the code blocks to define auxiliary things inside, like values, variables, and now auxiliary functions. Cool, so you now know about functions. Let's practice these functions with some exercises. I'm going to give you 4 tasks here. These are pretty simple. The first function that I want you to write is a little greeting function for kids. It takes 2 parameters, a name and an age. The name will be a string and the age will be an int, and it will say, hi, my name is whatever the name you give it, and so I'm just going to call it $name here so that you can insert name inside. And I am age years old. All right, so this is, for example, if I say the function with called with David and 12, it will say, hi, my name is David and I am 12 years old. All right, this is very basic. The second function that I want you to write is a factorial function, which is a mathematical function that computes the product of all numbers up to a given number that you pass in as a parameter. So factorial of n will compute the product of all the integer numbers up to n. All right, this will be a recursive function as a hint. All right, another recursive function will be a Fibonacci function. And the Fibonacci numbers are a stream of numbers where the first Fibonacci number is 1, the second Fibonacci number is also 1, and Fibonacci of n is Fibonacci of n minus 1 plus Fibonacci of n minus 2. All right, so this is a stream of numbers that just explodes exponentially. All right, so I want you to implement the nth Fibonacci number. So Fibonacci of n should return the absolute value of the nth Fibonacci number. All right, and finally, I want you to write a function which tests if a number is prime. All right, so pause the video now and work on these functions until I give you a solution. All right, so I hope you worked on these. Now, let's go through them. The first function with the greeting is very simple, but it's supposed to get you familiar with the Scala syntax for defining functions. So def, let's call this greeting for kids. And this gets a name as a parameter, which is of type string, and an age of type int. The return type of this guy is a string. And the implementation is going to be, hi, my name is a space plus name plus another string which starts with a space, and I am another space plus age, so I'm inserting age inside, plus another string with a space at the beginning, years old. All right, so if I print greeting for kids with David and 12, I'm going to see this in the console. So, hi, my name is David, and I am 12 years old. Okay, so this was very simple. Also, the factorial function is a very simple recursive function. So factorial of n, which is of type int, it also returns an int. And the implementation is going to be, if n is let's say less than or equal to 0, then just return 1. Okay. Otherwise, it's going to be n times factorial of n minus 1. All right. So if I print this out to the console, so let's just print factorial of, say, 5. That should be 1 times 2 times 3 times 4 times 5. So 1 times 2 times 3, 6, times 4, that's 24, times 5, that should be 120. So let's right click and run this. And we see the correct answer here just for us to test. All right, good. Now let's move on to Fibonacci. So def Fibonacci with the parameter n as an int. And this returns an int. And the implementation is going to be, well, if n is less than or equal to 1, all right, now we should return 1. We will ignore the case n less than or equal to 0 because that doesn't make sense. We'll probably throw an exception, but we'll learn about throwing exceptions later on in the object-oriented programming section in the course. All right. Otherwise, we'll just return Fibonacci of n minus 1 plus Fibonacci of n minus 2. All right. And the Fibonacci numbers are 1, 1. So these are the two Fibonacci numbers. And then the Fibonacci numbers are the sum of the last two. So we'll have 2, then 1 plus 3 plus 2, then 2 plus 3, then 3 plus 5, then 5 plus 8, then 21, and so on and so forth. So if we print line Fibonacci, let's say, so we have 2, 4, 6, 8. Let's print the number 21. So we should get the number 21 in the console. We have 34, which is 13 plus 21. We might have missed an index. Oh, that's because n is less than or equal to 2. That's why we said the first two Fibonacci numbers are 1. All right, so we'll see the number 21 here. All right, now finally, let's go with is prime, which receives a number n as parameter and returns a Boolean, which is the test whether n is a prime or not. And here I'm going to open some curly braces because is prime needs an auxiliary function. So these two previous functions, factorial and Fibonacci, wanted you to write recursive function. Is prime needs an auxiliary function inside a code block. And here I'm going to write an auxiliary function which tests if an n is prime up to a limit. So I'm going to define an auxiliary function, def is prime until, and I'm going to pass in a parameter t, which is an int, and this will return a Boolean. So the significance of this function is n prime until t? That is, does n have any divisors until the number t? All right. So the implementation of this function is going to be if t is less than or equal to 1, then it's going to return true because n is prime until the number 1. There are no divisors between 2 and 1 such that they divide n, right? Otherwise, I'm going to call is prime until recursively because is prime until t is basically is prime until t minus 1, and n should not divide t. So n mod t, this is the sign for the remainder of the integer division. This is the mod operator. You've seen this before. So n mod t not equal to 0. So t does not divide n. And the recursive call of is prime until with t minus 1. And our big function is prime will just call is prime until with n divided by 2 with the half of n. So the result of is prime is going to be the application of is prime until with n divided by 2. So is prime until is an auxiliary function that basically goes through all possible integer numbers starting from n divided by 2 until 1, and if any of those divides n, this guy will return false. So is prime until t will return false, which means that n will not be prime. All right, so this is a one possible solution for an implementation of is prime. There are multiple equivalent implementations. And just to test, if we call is prime with the number, say 37, which is a known prime number, or is prime with the number 2003, which is a bigger number but still known to be prime, we should be seeing true in the console. But if we try, say, 37 times 17, which is a non-prime number, we should be getting false. So we should be getting 2 trues and 1 false in the console. Oh, we should be calling is prime, of course. So let me call is prime with this guy of 629. All right, so we have true, true, and then false, which means that our is prime function works well. All right, so you've learned a lot in this video. You've learned how to define and use functions in Scala. You've learned how to use the unit type. You've learned how to define nested functions, and you've learned some basic recursion in Scala. I'm Daniel, and I can't wait to see you in the next video.